And this, to leap far ahead in our story, we think, in fact, is accounted for in terms of the hyperdimensional physics that we've been discussing on many times on your show. But that may be too detailed to get into tonight, or then again, maybe not. We have a lot of time.
Well, somebody's going to ask. They're going to say, all right, you've determined these objects are not natural by the use of your hyperdimensional physics.
Among other techniques.
Then they're going to say, this guy's a crackpot. Hyperdimensional physics? Come on. So, come on. What is it?
Let's not anticipate them until they say that. Okay?
Well, I can. I've been doing this a lot of years.
I got a medal for the physics from the Angstrom Foundation in Stockholm.
Thank you.
And Jonas Angstrom was one of the founders of the modern physics. And the Angstrom is the international unit used all over the world by physicists and scientists. And I feel extremely proud that foundation decided in 1993 to award me the medal for the physics based on our work on the monuments of Mars. Because frankly, I think of anything we've done, probably the physics itself is that which is the most important.
Well, okay, good. It's just the name that is going to throw people, hyperdimensional physics.
Why is it any weirder than quantum physics?
Well,
or population genetics, to coin a term from the O.J. Simpson
The answer
trial?
is because it's new.
Oh, well.
Well, so it's new.
Are we afraid of new things?
I'm not. I'm just trying to...
Actually, it's not new, Art. It's very old.
If you can...
The founder of hyperdimensional physics is not me.
Yes.
It is a gentleman named James Clerk Maxwell, who was an English physicist writing and working and studying and trying to figure this stuff out over 100 years ago in London. And he was basically the founder of modern electromagnetic theory. And it was he who coined the term hyperdimensional, not me.
All right. In a nutshell, what does it mean?
It means the physics of more than 3 spatial dimensions.
Oh, okay.
Length, breadth, and height we are familiar with.
Yes.
All right. Something can be deep, something can be wide, something can be high.
Right.
Well, suppose there are unseen dimensions, which cannot be seen with our current senses, but in fact can be modeled mathematically, and if you come up with the right amount of technology, might be detected with some kind of instrument, just as we can detect ghost particles at the subatomic level that you cannot hear or see or taste or touch. That's what hyperdimensional physics is. It is a physics of the unseen, but not the unavailable or the unaffectable.
In other words, proven by the end result of the mathematics.
Exactly. The predictive quality of a unified theory, which says that if this is going on behind the scenes, it should have this effect, and if you look in the real world and you observe the effect, then you have to believe the mathematics that leads you back to the cause, even if you can't see it.
I can accept that. Is there a way... Well, I'll tell you what, we're going to take a break here, but when we come back, I would like to ask you if there is a way in the real world that you can take what you know to be true mathematically and in some way reach out and prove it. Stay right there. Richard C. Hoagland is my guest.